Hi everyone, in this segment we are going to be talking about another type of stereocenter, EZ stereocenters. It is the case that in alkenes there is a restriction about the carbon-carbon double bond, and this affords EZ stereoisomerism in certain cases. Okay, to be an EZ double bond, each carbon of the alkene must have two distinct atoms or groups. Let's take a look at what that means. If you were to look at this first example here, we have two carbons. And on this left carbon, we have a ketone and a hydrogen. Those are two distinct groups. This carbon of the double bond has a hydrogen and a CH2Br group. Because each of those carbons has two different groups, this is an EZ alkene. Okay? This next one here, we have a carbon with a CH2OH, which is different from the phenyl, two distinct groups. This carbon of the double bond also has two distinct groups, ethyl and a hydrogen. And the idea is these are stereocenters because we could interchange two groups. Let's keep this right double bond carbon the same, but interchange the phenyl and the OH. We now have groups experiencing each other differently in 3D space. These were on the same side, now they're on opposite sides. Now E and Z is specifically looking at a difference in where the priority groups are in terms of are they on the opposite sides or the same sides. I'll be doing a separate video on how to determine priority and how to figure out EZ isomerism. For right now, I want you to understand that as long as each of the carbons of the double bond have two distinct groups, okay, two distinct groups, we can classify the double bond as E or Z, and there is stereoisomerism. We can have an E isomer, and we can have a Z isomer. Whoops, that should be a CH2OH. Sorry about that. So it's really important to think about this, and one funky exception that is good to know is cyclooctene. This is an 8-membered ring, cyclooctene. These carbons here are considered stereocenters. In a 6-membered ring, these two carbons of the double bond are not stereocenters. I will be making a separate video on why these are considered stereocenters, but note that is a funky instance of where we can see EZ isomerism. That is not the case for a 6-membered ring or a 5 or a 3 or a 4-membered ring or even a 7-membered ring. Okay, so E and Z refers to priority groups being either on the same side or opposite sides. And again, these do not interconvert, but we could imagine going from one to the other by the interchange of two groups.